today's problem from probability distribution of one-dimensional random variable. And the problem is, if capital X is binomial NP variate, so that P of X less equal to K, this is given by integration 0 to Q x to the power n minus k minus 1 into 1 minus x whole to the power k dx. By this integration is same whether q equal to 1 here. Okay, where q this is equal to 1 minus p, this is obvious for binomial NP distribution, and k is an integer which is lies between 0 to n minus 1. Okay, this is our problem. We first start from the left side of the problem, and clearly this is nothing but the definition of CDF, cumulative distribution function, or it is simply says that the distribution function. So what is distribution function? Here we already write the distribution function definition, and the definition is f of k. It is denoted by capital F of k, which is given by p of x less equal to k, or it can be written as p of minus infinity less capital X less equal to k. Okay, and it is defined by either summation or integration according as discrete or continuous. This is minus infinity to k fx dx, fx, or minus infinity to k fx dx. Okay, so we first write p of x less equal to k, and which is given by capital F of k, where we write here f of x be the CDF of x. It is right here, and it is defined by summation minus infinity to k fx. So we write summation minus infinity to k fx. But in our given problem, it is given that this is binomial NP. Okay, so here we write since x is, or we write since x is binomial NP. This is the symbol of binomial NP variate. So PMF fx, we write the same as here we write. This is NCx p to the power x q to the power n minus x, x equal to 0, 1, 2. This is 0, 1, 2, n, and this is 0 elsewhere. And p plus q, this is equal to 1. So here we write, or we take the summation from 0 to k, because there is no point in between minus infinity to 0. fx. Okay, and this is given by f of 0 plus f of 1 to f of k. Now putting the value of x equal to 0, x equal to 1, and x equal to k, we get the expression. This is given by p of x less equal to k. This is putting the value of x equal to 0, we get nc0 p to the power 0 q to the power n. This is the first. And f of 1, which is given by nc1 p to the power 1 q to the power n minus 1, and nc2, that is nc2 p to the power 2 q to the power n minus 2, and so on, nck p to the power k q to the power n minus k. This is our left hand side expression. Okay, so we get this is relation number 1. Now we start from the upper integration. This is the integration on the numerator, and clearly n, p, x, these are the variable, and n is the constant term because it is given that the binomial NP, this is constant, p is also constant, and here only variable is k, and this is given by the integer which is run between 0 to n minus 1. Okay, so we name this integration as ik, like reduction formula. Okay, and this is 0 to q x to the power n minus k minus 1 into 1 minus x to the power k dx. Right, now we integrate this integration by the rule of integration by parts, which is given by, we write this rule. This is well known and very easy rule, and we here take this term as b and this term as u. Okay, this is the first function, this is the second function, and integrating we get the result 1 minus x to the power k into integration x to the power n minus k minus 1 dx. This is the first term. Here the range is 0 to q, and minus integration. We first differentiate this term with respect to x, that is we write ddx of 1 minus x to the power k into integration x to the power n minus k minus 1 dx, and another dx is here. The range is 0 to q. And now from the first term we get 1 minus x to the power k into n minus k minus 1 into x to the power n minus k minus 1 plus 1. Sorry, this is not into, this is divided by n minus k, because 1 cancel out, and the range is 0 to q. And for the second term we get, this is integration 0 to q. Differentiation of this term is k into 1 minus x to the power k minus 1, and another minus 1 we get because this is minus x, so this is plus. And the integration of this term like this, so this is x to the power n minus k by n minus k into dx. Okay, and by putting the range of this integration we get, this is 1 minus q to the power k, and obviously this is p to the power k, because we know that 1 minus q, this is also equal to p. And from here we get q to the power n minus k by n minus k. From the first term we get, and if we put x equal to 0, then the second term or the contribution of the lower range is 0. Okay, now from this term we get k by n minus k into integration 0 to q. This is x to the power n minus k into 1 minus x to the power k minus 1 dx. Okay, and now if we compare this integration or starting integration with this, it is clear that here we put k minus 1 in place of k. Okay, so we write this term as, this is p to the power k and q to the power n minus k by n minus k, plus this is given by k into n minus k into I k minus 1. Okay, if we put k minus 1 in place of k, then this is x to the power n minus k, and this is 1 minus x to the power k minus 1 dx. Okay, so we write this result. Okay, and our recurring relation we get here, this is ik, this is given by p to the power k q to the power n minus k by n minus k plus k by n minus k into I k minus 1. Okay, and from here we get ik minus 1, which is given by p to the power k minus 1 q to the power n minus k plus 1. Here we put k minus 1 in place of k by n minus k plus 1. Okay, plus k minus 1 by n minus k plus 1 I k minus 2, and we put the value of ik minus 1 from here. Okay, and getting the result here as p to the power k q to the power n minus k by n minus k plus k by n minus k into this term, this is the ik minus 1, so we get the result p to the power k minus 1 q to the power n minus k plus 1 by this is n minus k plus 1 plus we get by multiplication k into k minus 1 by n minus k into n minus k plus 1 into I k minus 2. Okay, and in similar manner, if we put the value of I k minus 2 from here, again we get I k minus 2 by putting k equal to k minus 2 here, or we put here k equal to k minus 1, we get the same result, that is I k minus 2. And here we write the value of I k by putting I k minus 2 in terms of I k minus 3 from here. Okay, and we get the recurring relation as p to the power k q to the power n minus k by n minus k. This is the first term as here, plus the second term is given by k by n minus k into n minus k plus 1 into this is p to the power k minus 1 into q to the power n minus k plus 1. And by putting here the value of I k minus 2, we get the value, this is k into k minus 1 by n minus k into n minus k plus 1 into n minus k plus 2 into p to the power k minus 2 into q to the power, this is n minus k plus 2, and another term is here, this is k into k minus 1 into k minus 2 by n minus k into n minus k plus 1 into n minus k plus 2 into I k minus 3. Okay, now if we proceed this procedure, then we get the similar result. Okay, as p to the power k q to the power n minus k by n minus k, this is the first term, and we write the second term here, this is n minus k into n minus k plus 1 into p to the power k minus 1 q to the power n minus k plus 1. Okay, and similarly we write the last two term. If we first write the last term, okay, then we write the previous term. The last term is given by, if we take this term be I0, okay, because in each step the suffix of I is decreases by 1, then it is ultimately I0, and then the numerator is obviously k into k minus 1 into k minus 2 to, here it is a similarity, this is k minus 3, then this is k minus 2. So this is 1 greater than the suffix. So here is 0, so we get this, the last term is 1 and the previous term is 2 and so on. Okay, and the denominator term is given by n minus k plus 1 and so on. The last term is, it is seen that this relation or this term is n minus k minus 2. Okay, so this is n minus k plus 2 and the suffix is a k minus 3. So we must have to subtract n minus 1 greater than the suffix. Okay, so the suffix is 0, so we get here n minus 1. This is the last term, and the before term is n minus 2. Okay, this is our complete relation, or this is our complete value of I k. Now we have to find out the value of in numerator. Okay, this is value of this integration in denominator. And what is the value of this integration? It is clear that the integration in numerator and denominator is same, integral is same, but only the range is 1 in place of q. So we write this integration, that is the integration 0 to 1 x to the power n minus k minus 1 into 1 minus x to the power k dx, this is also equal to I cube, but we put here q, this is equal to 1. Okay, and when we put q, this is equal to 1, then p, obviously this is equal to 0. So we get the value of this integration by putting p equal to 0 and q equal to 1 from here. Okay, and we easily get the value of this integration. There be only one term remains, because in all term p is present except the last term. Okay, here we first find the value of I0. What is the value of I0? I0 is given by, we get from here, what is I0? I0 is integration. We write this integration again. This is 0 to q. This is h to the power n minus 1. Okay, h to the power n minus 1 into 1 minus x to the power 0 dx, because we put k equal to 0. And from here we get the result as, this is integration 0 to q, and this is x to the power n minus 1 dx. So obviously this is x to the power n minus 1 plus 1 by n. Okay, and this gives, the range is 0 to q, so this gives q to the power n by n. Now we put here directly the value of I0, this is q to the power n by n. Okay, so the value of this integration is only this term by putting q equal to 1, and other term is 0, because all the other term here p present, and by putting p equal to 0 we get all the term other than the last term is 0, and the value is given by, clearly the upper term is k factorial, because this is 1, 2, 3 to k multiplication, and the lower term is given by, n minus a plus 1 to, this is n, the last term is n we get, and here another term is q to the power n. Okay, and if we multiply numerator and denominator by n minus k minus 1 factorial, then we get here, this is n minus k minus 1 factorial, and this gives our result as, if we expand this factorial, this is 1, 2, 3 to this, and together with the existing result and with the multiplied result, we get the value as k factorial into n minus k minus 1 factorial by n factorial into q to the power n. Okay, this is the value of the lower integration, and here also q equal to 0, because here q is 1, so we get q is 1, so this is 1. Okay, we get the lower integration is this. Now here we divide our result in ik. We get ik by, this is ik by, this is k factorial into n minus k minus 1 factorial by n factorial. Okay, that is, we have to find the value of n factorial by k factorial into n minus k minus 1 factorial into ik, and this gives the result as, from first term we get, this is n factorial by n minus k minus 1 factorial into k factorial. We write in the outside of the bracket, and we write the value of ik here. This is p to the power k, q to the power n minus k by n minus k. The second term is k by n minus k into n minus k plus 1 into p to the power a minus 1 into q to the power n minus k plus 1, and similarly we write the last term here. This is k factorial by, this is obviously from here we write, this is, if we multiply the numerator by n minus k minus 1 factorial, then we get from here, this is n factorial into q to the power n. Okay. Now if we multiply by this term with each term of the bracket, we write the last to first term. Okay, and we get the first term as q to the power n, because factorial n cancel out, this term cancel out, and k factorial cancel out. And similarly, if we multiply this term with the previous term of the last term, then we get the result as n, only n is here, into q to the power n minus 1 into p. And similarly, we get the after term is n into n minus 1 by 2 factorial into q to the power n minus 2 into p square. And similarly, we get the last term as, this is given by our this term, and we get that n factorial by k factorial into n minus k factorial into, it is here, this is p to the power k into q to the power n minus k. This is here, and we get n minus k minus 1 factorial into n minus k, so we get n minus k factorial, and k factorial is here and n factorial is also here. Okay, so we write, this is f0, this is f1, this is f2, and this is clearly fk. Okay, and we say that our ik is this ik, and our lower value of this is the lower integration, so we put this integration by this integration, this is equal to f0 plus f1 plus f2 to fk, and which is given by p of x less equal to k. Very important problem of probability distribution, but lengthy problem. Okay, thank you for watching.